Today is officially the day. I've gotten a lot of requests for videos about how to make tools and about how to create tool cribs and things like that and tool assemblies. So today we're going to go over that in a video. The first thing that I'm going to start off with is the MasterCAM Tool Manager. So I'm going to go through a couple ways to make tools. One would be just a quick way of making it within MasterCAM. Hypothetically, you have a part that you have a specialized tool for, and you just want to create that tool, make that. You're going to make it one of them. Probably the only time you're going to ever use this tool, or very rarely going to ever use this tool. The second way, or the first way that I'm actually going to go over is it's going to be actually making the tool and an assembly, assuming that you're going to be using this tool in the future. And it's going to show you how to create a database and all that stuff. And you can basically pull that in. All of your speeds and feeds will be correct every time. This is really the way that I recommend. If you think you're going to use a tool more than once, it's worth it. So let's begin. So the first thing you need to do is you need to bring Tool Manager up. So I'm just going to go into my Start menu. And you can get to it through your machine. And let me see here. You can get to it through. Oh, you actually have to have your tool. You actually have to have a machine called up. So I don't have a machine in right now. So I'm just going to go through the Start menu. So just go down to MasterCAM and right here, Tool Manager. So it takes a second to open, just like everything does with MasterCAM. So while that's opening, what we're going to create today is a Kennametal. We have a very large Kennametal thread mill here. Generally what we use this for is to create the grooves on our chuck jaws for our CNC lathes. So this is actually a 1.5 millimeter pitch. It matches what our chuck jaws use. And we're going to create this end mill or thread mill so that we can make that. We're also going to make an assembly. So we have this 1-inch holder here, solid end mill holder, which somebody was handling that has the rust touch. So it's in a little bit of dire need of some Scotch-Brite to get that cleaned up before we use it. But we can get our measurements off of it for now. Okay, so this is what's going to come up. So you're going to end up with a start page here. And actually, you can go through a lot of this stuff, creating holders. And this will help you out with the really in-depth details of how to create stuff. But I'm just going to go over how to create tools. And I'm actually not going to create a holder, but I'll show you how you can create. Actually, no, I am going to create a holder. I lie. I'm going to need to modify a holder. I usually don't create them from scratch. So we'll go all through all that. But this, if you ever have trouble, this is a good place to start if it's something that I haven't gone over. Okay, so I'm going to click out of there, and I'm actually going to open. And in my shared 2022 mill tools folder, I am going to pick my cat. Actually, let's make this let's make it a cat 40. So we'll pick our cat 40. And you want to import your holders first. So just open your holder file. And cutting tools, you can see I already have a cutting tool in here for some reason. So I'm going to double click that. Open that up. Engraving bit. We're going to delete that out of there. We don't want that in there. Okay, so now I have the ability here. I have all my holders. So if I double click on my holders, you can see I got all my Cat 40 holders. And I think my Cat 40 actually has everything. And I actually combined these to include all holders, even like HSKs and stuff like that. So I'm going to open that up. And as far as cutting tools, if I click on that, and it appears up here once I double click it over here. I don't have any cutting tools now. I deleted that one. So to get started, what I'm going to do is I'm going to model this, or I'm going to basically define this cutting tool and get the dimensions and stuff like that off of it. So let me grab my calipers here. Okay, so I know we have a 1-inch shank, but first, before we do anything, we have to select what type of tool we want. And for my drop-down menu, I have a thread mill here. And it's saying Unified National. In this case, I am using metric. As I mentioned, it's a 1.5 millimeter pitch. Threads per inch. Okay, so this is where it gets a little goofy. it still gives you threads per inch, even though you're selecting metric. So it's kind of a little bit of a pain in the butt. So you have to figure that out. To figure that out, we have 1.5. So I'm going to take 1.5 and I'm going to divide that by 25.4. And that means our pitch is 0.059. Okay, so if I got 0.059, then I need to divide 1 inch by 0.059. So 1 divided by 0.059. And that gives us a threads per inch of 16.949. So we'll add that in, 16.949. All right, so that'll give us our correct pitch. Unfortunately, it's just in English, or in imperial rather than. Okay, next, cutting length. All right, this is easier to do than some of them, so we'll do our cutting length. Cutting length is 1 inch, so that's perfect. Overall length, I have a scale over here. That'd be a little bit more helpful. It looks like our overall length is about 5 3/4. Say 5.75. Our outside diameter. All right, so for this, it's a little goofy. So we have a one fluted, you can see that. It's a one fluted thread mill. So what I need to do is I need to measure over the neck, and I got 0.94 roughly. 94. Then I'm going to measure over the actual insert, and I'm going to look for the largest diameter. I'm not going to measure over the flat. So if I'm measuring over the flat of the insert, that's not really going to give me my largest diameter. I kind of need to twist this a little bit. And it looks like my diameter there is going to be 1.065. So 1.065. Okay, so if I subtract 0.94 from 1.065, I get essentially 1/8 of an inch. So basically, this is sticking out 1/8 of an inch. So basically, I'm going to add 2 times 1/8, which is 1/4 of an inch, to that 0.94. So 0.94 plus 0.25. And I get 1.19, which makes sense. It's 1 3/16 essentially. So my outside diameter, 1.19. And this doesn't have to be perfect the first time. If you're putting it in and it's not, it's not perfect the first time, that's fine. All you're going to do is just put an offset in your tool at your machine. Just tell it that the tool's a little bit bigger than what you think it is, and run it. See if it cuts to size. Whatever it's off, that's how far your tool's off. So you can come back and adjust this once you figure that out. This is a hard tool to get a perfect measurement because it's a single flute. 3 flute is another one. Unless you have a V mic, very difficult to measure those. Okay, so 1.19 our outside diameter. Overall length's good. All right, shoulder length. All right, so our shoulder length looks like 3.5 inches, 3.5. And shoulder diameter, that's 0.94. Shank diameter is 1.0. All right. So there we go. There is our thread mill. Now I can't really see it very well, but when you zoom in, you can get a good look at it. All right, so it's a straight tool. So we've pretty much defined everything we want to define there. Finalize properties. This is where you're able to essentially assign it a tool number. So if this was a tool that I was going to use all the time, I was going to leave it in the machine, maybe as like tool 8 or something like that. I was using it for a standard job and it was almost always in there. What I would do is I would assign that a tool number 8. In this case, it's a random tool for me. not using it every time, so I'm going to assign it 29. I use tools 24 through 29 as tools that I could just swap out in and out all the time. So I'll just pick randomly one of those numbers usually, and sometimes I'll have to change it when I pick it. When I'm programming, I'll have to change it to a different number because I'll have two 29s, but generally speaking, it usually works out. So offset 29 makes sense. Head, I don't need to worry about that. I only have one head on this machine. Surface footage. So for the surface footage, these inserts they run at about 500 surface feet. And feed per tooth, we want to take about 0.015. Oh, check that, 0.015. It is a one flute tool. Oh, check that, sorry, 2.25, there we go. So we're taking about 2.5 thousandths per chip per tooth. We have one flute. We're running a 500 surface foot, so our feed rate generally is about 4 inches a minute on this. Of course, this is in steel. Let's see here. Plunge rates, 25 inches a minute, 50. That's fine. Spindle speed. You can see there, calculates my spindle speed for me. It's clockwise, it's carbide. We are good with everything here. I don't need to worry about these step overs so much, but I can define this stuff if I want. So if I wanted to define a rough step over for this tool, it would automatically put that in for like my dynamic milling and things like that. It would just automatically default to that. So I'm going to go ahead and finish. Okay, so there's my tool. All right, so I got my tool. Next, I want to create a holder. So I'm going to go to my holders, and this is actually just a blank. That's just a blank Cat 40 upper. So I'm actually going to go to something and find something that's kind of close to what I have. Okay, so wait, that actually wasn't bad. Yeah, that's not too bad. So let's see here, my holder. I find something close, and then I'm going to duplicate that. And then I'll hit name, name. Now I forgot the name of it, so I lost it. There it is. 1500. There it is. So there you can see I have the duplicates of it. And actually I have duplicates of everything. So I'm going to go in there and I'm going to actually edit this. I'm going to double click on it. And I'm going to start clicking on these. And when you click on them, you'll highlight the portion that it's showing. So this is defining that top portion. This is defining the angle. This is going to define the flat or the next angle. That's going to define that flat. Okay, so here's where I want to begin because I don't want to change the Cat 40 connection up here. I just want to change the lower part. All right, so, and I'm taking rough measurements. These don't have to be perfect. So this is 1.75. Okay, so it's got a 1.75 diameter, the height of it. Let's see what we got for that. It's about 0.6. So change that. Bottom 1.7. Okay. And then this one here, we have 1.75. Measure this, 2 inches in diameter. So the top is 2. And the distance of it, if I take just a rough measurement, it's about 100 thou. I'm going to make it 0.125. That's probably pretty close. Okay, so I know this one is 2 inches. I know the bottom's 2 inches. The distance on this is going to be 2 1/8. 2.125. This is going to be 2.0. So I have this last chamfer here. And it looks like that's about 3/8 of an inch, so that's correct. I gotta see what the diameter is. Now there's a radius at the bottom of this, but again, I'm not worried about it being perfect. I'm gonna say 1.65 for this. Okay. All right, so that looks pretty much like my tool. So that's all I needed right there. ID. It's an ID holder. Don't really need to identify anything there. Let's finalize the properties here. And I can call this cat 41 inch 1 inch solid. And that looks good. It does take through coolant for the record. And I'm going to go ahead and hit finish. Okay, so now obviously you don't see a hole in here. That's fine. You don't need to tell it that there's a hole. It's basically already, we actually do need to put 1 inch there. Finish. Okay, so now once we have our holder created and once we have our tool created in this case, what we're going to do is hit assembly, and that is actually going to create us a new assembly here. So you have to hit this button up here, assembly, and that's going to create a new blank assembly. Then what you can do from there is you can come down and you can grab your holder, grab our Cat 40 1 inch solid, and we're going to drag and drop it in there. And then I'm going to go down to my tools, and I'm going to drag and drop my tool in there. Notice that I drug them in out of order. I don't want the tool above the holder, right? Because the tool goes into the holder. So make sure that you assemble them correctly. So if we click on that assembly, you can see that it looks like this. Well, that's hanging out a little too far. So if you click on these down here, you can actually see the properties for each one. You can change them for each one. There's our holder and then our assembly. So for instance, our tool projection is something that we want to change on the assembly. We know that we have 3.5 inches of shoulder length. So we're going to make that I'm going to make it 3.6, just stick out a little bit further than shoulder. And then our tool number, where is it there? Tool number, yeah, I'm right on it. We wanted that to be 29. Now, we set it for the tool, but we didn't set it for the assembly. So we need to set that for the assembly so that it stays 29 if we pick the assembly. Because when we get into MasterCAM, you'll see that I can actually pick just the tool, or I can pick the whole assembly. So I'm going to pick 29, or hit 29, enter, and there we go. So now our assembly is tool 29, have a stick out of 3.6 inches, and we have the correct holder. Okay, so now that we have that, what I'm going to do is I'm going to go File, Save As, and I'm going to save this as Thread Mill Test. So I'm going to save this as its own. It's basically going to be its own library, its own tool library. So I'm going to hit Save. Yes, I want to replace it. Okay, so that was just creating one tool. Now what I would do generally is I would create all of the tools that I normally use, and I would just start building a library for all of the tools that I use. You can always go back in and delete them if they become antiquated, you don't use them anymore. But generally what I do is I put all my tools in one tool library. In this case, I would probably create one, and then I would say duplicate, and I would then go in and I would click on this, and I would say it's still tool 29. So I change that, and I'd go into the thread mill, and you can see here my cutting speed. My surface footage on this one is still 499, 500. Well, let's say I wanted this one to be an aluminum cutter, right? I wanted to use this one to cut aluminum. So this one I'm going to make 2,000. All right, so you can see it changed my spindle speed. It's going to change my feed rate significantly. My feed per tooth might change to 0.005. So now my feed rate changed quite a bit. And I'm going to name this one ALU. Oops. I'm already in cap lock. ALU. Okay, so that one's for aluminum. And I might actually go back into this one, and I might name this one STL. So that way I have one for steel, one for aluminum. And generally, that's what I do with my tools. I'll create them for different materials. So I'll create duplicate tools for different materials. and then I can just use one tool library to select whatever I want, assuming that these tools overlap. So like an insert mill, in this case, I have inserts. These inserts really just come for steel or aluminum. I can use that. You can also get specialized inserts. So depending on what you're doing there, you may have duplicate tools. You may not. You may have specific tools for aluminum. So whereas I might have a 4-flute end mill that I commonly use for steel, I may have a 3-flute end mill with a 45-degree helix that I use for aluminum. So it's not exactly the same tool, but it's still a 1/2 inch. So you would duplicate that and just define it as best you can. That way it's easy to pick out when you're going and selecting it. So I'm going to go ahead and hit save again. I'm going to save as. Save. Yes, I want to replace it. All right, so let's go into MasterCAM. And let's create a toolpath. So I'm going to delete that. All right, so we have contour. I'm just going to select an edge here. Check. And I'm going to go in, and you can see I already had these selected. My first time I recorded this, it didn't record correctly. So I'm going to select library, and I'm going to go and I'm going to pick my thread mill test library. Open. And you can see here nothing pops up. I can pick tools, both. If I turn off my filter, it should pop up. Okay, so there we go. So I have some other goofy stuff in there that I could probably get rid of. But you can see I have my 2 assemblies in there as well. And what I meant earlier was if I have both on, I can just select that tool without an assembly. So if I pick assemblies, it's just going to narrow it down to that steel and aluminum one. If I pick just tool, it's just going to give me the tool. So let's pick this for steel. See here, all my feeds and speeds came in perfectly. So I don't even need to address those anymore. Tool number. Notice my tool number didn't come in correctly. Let's change that. So there are a couple of things, a couple of caveats here. So if I X out of here, no, I don't want to keep that. If I go into my tool settings, number 1, my speeds and feeds will always come in correctly as long as I have feed calculation from tool. If I have it from material or from defaults or user defined, the number will not be correct. So it'll calculate it from this material down here or from something else. Assign tool numbers sequentially. If I have this checked, it's going to automatically override whatever my tool's set to, and it's going to name it number 1, 2, 3, 4, and so on. So I have to uncheck that for it to bring in my correct tool number. So I'm going to go ahead and hit check now that that's set. And I have that set generally for the VF2s to just number them 1 through or sequentially. But in the VF4s, the 5-axis machines, I have it set so that I have tools. So we're going to hit end, check. Okay, so let's go ahead and see we got goofy numbers in here. Our numbers definitely don't match what we put in. Let's go and select our tool. Unclick this. We're going to pick it for steel. We got tool 29, and all our speeds and feeds came right in. Holders in there, exact stick out is in there, everything is defined. This is absolutely fantastic when you're programming in a 5-axis. If you've watched any of our 5-axis programming videos, you probably have heard me say 1,000 times that it is very important that this is pretty close to correct. I mean, I'm not talking about within 1,000. If it's within 10 thousandths or so, you're probably not going to hit. Of course, that depends on how much you leave for it, a gap between your tool holder and your part when you're doing your collision avoidance. But the closer you have this to being correct, the better your simulation is going to be in MasterCAM. That simulation is absolutely fantastic. It will give you a lot of confidence in running the machine when you go out there for the first time. It'll give you, even when I run this and I see maybe it's getting close, it tells me where I have to really watch closely when I'm running it for the first time. Now that being said, a simulation that runs correct is no substitute for putting it on 5%, turning everything down the first time you run it, and making sure you have your finger on the feed hold button. I'm always extremely careful the first time I run it, no matter what. I don't care what the simulation shows. but the simulation is right 99% of the time. In fact, I've actually never, I don't think I've ever had it rub, or I don't think I've ever had it, I don't want to say crash, but gouge or anything like that when the simulation didn't show it. So simulation is pretty accurate. But again, no substitute for running it very slow the first time. So that's it. That's basically how you create a tool. Yeah, a tool crib, and how you call up your tools. So, by the way, if I wanted to just call up the tool, I could do that here. Let's call up my thread mill, and you can see that it's calling it up. But now when I go to holder, I would actually have to go and select the holder. It just puts a generic holder in there. So I'd have to go to open library, go into my Cat 40, then I'd have to go and select, my Cat 40 holder that I thought was appropriate, wherever that be, and so on. The other way that I can create a tool, as I mentioned, there's two ways. I can also just go in here and I can right-click. If I'm going to create a tool, I'm just going to use this tool maybe one time. Very rarely ever going to use this tool. It's a specialized tool. I can just go to Create Tool here and just select what I want, like a thread mill. You can see all of this dialog box is the same. Everything here is the same. You can set all that stuff, hit Finish. There's your tool. Then if you want to add a holder, you can just go in and you can change the holder. So if I go to Open Library, in my case I'm using Cat 40s pretty much exclusively. So I can go down here, and these are B's. I need a cats, so I need to go to C. I remember I put all of mine. I put all the BTs in here, put all the cats, and put everything into one. Actually kind of regret doing that now. But as you go down, so you go to C4, that's Cat 40. And these last numbers here, by the way, this number here, this C3, that's your gauge lengths. So as you start to go up here, you see you get longer gauge lengths. So it's like a 5-inch gauge length. But anyway, I want about a 2.5-inch gauge length, and it rounds to the higher number, obviously, because it's only one digit. The last numbers are your ER collet numbers. So this is an ER32, ER25, ER20, ER16s here. So let's say I want an ER32, 2.5-inch gauge length, and I want my stick out to be 1.5. And then I can give that assembly a name if I want to. So essentially that's how you create a tool really quickly. The other way, coupled, when you create an actual tool crib with the correct speeds and feeds, the correct tool numbers, that coupled along with setting your operation defaults really, really decreases the time that it takes to program parts. So I believe that's all I have. If you have any questions or comments, leave them in the comments for the video. And as always, if you have questions, you can see me in my office hours or, of course, during class.